Let's continue through 4.3, and in this part of the lesson, we're going to be introducing the mean value theorem through a little activity. So let's start. This first activity, we're going to start here. Draw a secant line between the 2 points. So secant line is basically just to connect the dots. So that right there, that's actually your y2 minus y1 over x2 minus x1. That's slope. Rise over run, your average rate of change. So that right there is called a secant line, connecting those dots. Next, I want to draw a tangent line that is parallel to the secant line. So a tangent line touches the curve at exactly 1 point. So I could have something like that. I could have it touch the curve there. I could have it touch the curve there. Those are all tangent lines. And I specifically want to draw the tangent line that's going to be parallel to this secant line. So it looks like about there. Those are parallel. So essentially what we're saying is the slope of this tangent line is equal to the slope of this secant line because they're parallel. That's what parallel means, that the slope is the same. Let's try that in number 12. So we draw our secant line. And now we're going to try and draw some tangent lines that are parallel. So it looks like I could draw one there. And it looks like this one, I even have a second one about right there. So there we go, tangent lines that are parallel to that secant line. Okay, let's try number 13. There's my secant line. Let's try and find a tangent line. Okay, well that one's not parallel. That's definitely not parallel. That one's not parallel. That one's not parallel. And I can't draw one there because that is a sharp turn, which means the derivative, or the tangent line, isn't going to exist. So that one doesn't have a tangent line. Okay, well, that's interesting. Put that in our back pocket and keep moving forward. This one, if we drew our secant line, it would be like that, but we can't cross an asymptote. We can't cross an asymptote. So, this one doesn't have a secant line between those 2 points. And if there's no secant line, there's definitely not going to be a tangent line that's parallel to it. Okay, let's do number 15. Between A and B. Well, that's an asymptote. So, can't have a secant line on that one either because it never ever ends. It's just going to keep going down and down and down. It's never going to touch A. So that one doesn't have a secant or a tangent. Okay, let's try 16 then. So there's our secant. We can draw a secant this time. Good, so far so good. Now let's draw our tangent that's parallel. Well, it would be right there, but that's a hole. So that point doesn't exist. So if the point doesn't exist, I definitely can't draw a tangent line on it. So that one doesn't have a tangent line. So let's start to summarize this then. The idea behind this is that we want to figure out what conditions are there that allow there for a tangent line to be drawn. So what conditions have to be met in order for a tangent line to exist? Well, our first condition, if the tangent line is going to exist, the secant line needs to exist. If there's no secant line, there's not going to be a tangent line that's parallel to it. So if for the secant line to exist, if we look at these problems where it doesn't, it looks like we need to be continuous on the interval. So from A to B, we need to be continuous. If it's not continuous from A to B, we're not going to have a secant line there. Okay, so let's try. So we know the secant line exists, it's continuous. Well, let's think of our second condition. If the secant line exists, so like on 13 and 16, why doesn't the tangent line exist on these? So if the secant line is there, in order for the tangent line to exist, if you look at number 13, not only does it need to be continuous on the whole interval, it needs to be differentiable. So no sharp turns. So those are the conditions. If it's continuous and differentiable, then secant line is going to exist and we're going to have a tangent line that's parallel, at least from these examples. Well, that actually is the foundation for the mean value theorem. So we're actually going to skip 17, 18, and 19. Here's the mean value theorem. And it has the conditions we just laid out. Condition number 1 is it needs to be continuous on the closed interval, the whole thing from A to B. Condition number 2 is it needs to be differentiable from A to B. And it doesn't so matter if it's differentiable at the end points, just in the middle. So those are our two conditions that we came up with. So it's saying if these conditions are met, if it's continuous and differentiable, then there's going to be a number C where these two things happen, where the slope of the tangent line, or the instantaneous rate of change, that's f prime of C. So the slope of the tangent line is going to equal the slope of the secant line, which is what we were doing. They're parallel, they're equal to each other. So the slope of the tangent will equal the slope of the secant. Or in other words, at one point, the instantaneous rate of change will equal the average rate of change, which is kind of a cool idea. So now that we understand that, we can go back to 17, 18, and 19. So here's our secant line. It is continuous between 2 and 5. And it's differentiable between 2 and 5. No sharp turns. So that means we're going to have a tangent line that's going to be parallel. And there it is. And then we can say, where is that tangent line? It's right there. It's about at 3. Okay, we can do the same thing over here with this one. There's our secant line. It's continuous on the whole interval. It's differentiable on the whole interval, except for the endpoints, because those don't matter as much. So there's going to be a place where the tangent line equals the secant line, or the slope of them. Well, it looks like I have one there. That's where the slope's the same. And one there. That's where the slope is the same. So this one touches at about there. So that's going to be like 2.5-ish. And that one's right there at like 4.2-ish. So that's all we're saying, is we're finding that secant line, finding the tangent lines that are parallel, and what point is it that gives the average rate of change equals the instantaneous rate of change. So in the next video, we'll do an example problem where algebraically we go through and apply this theorem.